So, hi everybody. My name is Fraser Cain. I'm the publisher of Universe Today, and it's time for your virtual star party for February 24th, 2013. So once again tonight, we're going to hook up a whole bunch of telescopes into a live Google Plus Hangout, and we will show you the night sky. I said to mute, Stuart. We're going to show you the night sky live. So we're going to show you, we got a nice live view of Jupiter tonight. I think we'll be able to get the moon, although it's almost full moon. We're going to be able to get a bunch of deep sky objects to be able to show you as well tonight. So I think it's going to be a good night. Now the problem is we've got this almost full moon, which is going to be pretty bad news for being able to see a lot of the deep sky objects. So we're going to have to kind of deal with that. So joining me tonight, we've got this is great. It's like a reunion of a lot of the people who joined us early on. So we've got Chris Ridgway.
Hello.
Hey, Chris, and he's showing us this view of Jupiter tonight.
Not very well, but
not very well.
Got a transfer to dust across the face of it.
Yeah, you've got a couple of. No, we're going to call those transits of dust motes. So those aren't actually moons of Jupiter, unfortunately.
Newfound storms, maybe.
Newfound storms. Yeah. We got Gary Gonnela. Hey, Gary.
Hi guys.
We got Louis Bamakos, who he's showing us an archived photograph, so definitely not a current photograph. But he's clouded out tonight, but he's going to join us for color commentary. Maybe show us some of the pictures that he's done, because he's got some beautiful pictures that he's taken. We got Mark Barrett in Chicago, and Mark is showing us also the Orion Nebula.
Hi guys.
This is great. Mark was one of the first people to join us back in the, like a year ago in the star parties. Back in the day, yeah.
He's so old school, Mark.
He's totally. Got Dr. Pamela Gay, my co-host on Astronomy Cast. Whoa, where's that coming from? Oh well.
That was my phone vibrating, telling me that the virtual star party just went live.
Oh, okay, yeah. Thanks.
Hey, guess what, Mark?
Virtual star party's gone live. Yeah, just in. So Dr. Pamela Gay, my co-host on Astronomy Cast, she's going to bring the PhD astronomy knowledge tonight. Scott Lewis, my co-host for the Virtual Star Party.
Hey, everyone.
The person who does all the things. All the things. And Stuart Forman, who's located in San Francisco and is showing us this beautiful view of the Orion Nebula as well. And what's really great about this picture is you can see the trapezium, which are those 4 stars right at the heart of the Orion Nebula, and because he's done actually a very short exposure on this picture. So, Stuart, do you want to talk a bit about this picture?
Sure. This is a 10-second exposure at ISO 400, so it's pretty dim. But I did that specifically since I didn't want to blow out the core. And and it's also very heavily cropped. And I have an uncropped M42 kind of in the queue here, which I'll show you in a second so you can see the difference. But in the middle of the core of the Orion Nebula, there's 4 stars, which are called the trapezium. And Pamela can tell us more about the science behind those. But you don't normally see those in our M42 shots because we take 60 to 120 second shots, and this area gets completely blown out. And you'll see that in my next picture I'll show. It is completely blown out. You cannot see them.
What I think is great is all through the summer, everyone is asking us to show them images of the Orion Nebula, and the Orion Nebula is down over the summer, and then it comes up in wintertime, and then we're going to get, we get really beautiful pictures of the Orion Nebula, and now we have 4 of them. So for all the people all the summer long who asked us for images of the Orion Nebula, here are 4 simultaneous images of the same object. But yeah, so you can see here, I'm showing you Gary's view right now, and you can really see how just the center of the nebula itself is just a big white blob, with the rest of the nebula, a lot fainter, and it's a lot more, subtle. But that core part is just so bright that it's just white. And then with Mark's view, same thing. You can really see. Mark, you can really see the trapezium in there, just the 4 stars.
Yeah, if we go in pretty close, we can see the trapezium in there, and you get some of the finer detail in that big blowout area. The real trick is to get a bunch of exposures across all sorts of different range, so you can get some detail on everything.
Yeah, it's one of those. It's that technique of doing the high dynamic range, the HDR, and that's how you get those really cool images. We see a lot of them on Google Plus, right, where they'll take an image at a at a really short exposure, and then they'll do a medium exposure, and then a bit of a longer exposure, or different apertures, and then they'll merge that image together, and so you get detail on both the sort of fainter items, but also detail on the stuff that would be really bright and be overexposing the rest of the image, and you can really see that subtle detail. But these are just one exposure that people are doing. And then here's Stuart's view, as promised.
Yeah, so this is the uncropped view in my f7 refractor, and you can see how much smaller it is. And this is a 122nd exposure, and so you can see some of the nebulosity on the outside. It's kind of pretty.
And this is with a full moon.
Correct.
Yeah.
Yeah, kind of pretty.
Yeah. It could be better, Stuart, if you didn't have fun.
I know.
No, that's amazing.
Yeah, it's an amazing image.
Yeah.
Wow.
I can't believe
and
this.
not only is it a full moon, but the moon is very near Orion to be particularly annoying.
Yeah. And I have a street light across the street, but who's counting?
Yeah. I was taking some pictures. I was doing like a time lapse with my with my DSLR, and it was really great, but the whole picture was taken on this red color, and I couldn't figure out what the problem was, and it turns out there was a street light, and the light was coming in the side of the lens and then just overexposing the sort of the background of the whole picture, and so just every image kept getting red and red, and I couldn't figure out what the problem was, and it was this street light, and so I just needed to turn the camera away, and then it was fine.
Or a pellet gun.
Or a pellet, yeah. I would love to shoot out that light. That light just shines right through my window and just drives me crazy. I would love to get rid of it.
Well, the other trick, Fraser, is to shine the laser on the photosensor to think it's daytime and make the light go out.
Really? I have a laser.
Those are dangerous words. Hearing Fraser go, I have a laser.
I have a laser. That is.
I think he's been practicing the Dr. Horrible laugh to prepare for that.
Yes.
That is fiendish. I'm totally gonna try that. Will I go to jail?
Only if you get caught.
Most likely not.
I was going to say, probably not.
Probably
That's
not.
a good idea. I got to try that.
Her, though.
I'll try it first, Fraser, and then I'll tell you if it works.
That's a great idea. That's right. You hit the photosensor.
Just so you all know, we're going out live to a large audience of people who can figure out where you live.
What? To tell if I've turned my streetlight off? Yeah.
We do not advocate for the destruction
we don't.
of city property.
That's a terrible idea. And if tonight my streetlight is somehow turned off, it's purely coincidence. It wasn't me. So just to remind everyone, we're glad to answer any questions you have about space astronomy, about gear, about telescopes, about cameras, technique, and even just general science stuff, because we've got a PhD astrophysicist here with us, and a lot of combined astronomy knowledge and observing knowledge and astrophotography, so it would be great. Now, there's a bunch of places you can ask your questions. You can ask your questions on the event page, which is on Google+. You can ask your question if you're in the stream, like, on Google+. If it's in like my posting or someone else's, a reshare of that, we'll try to catch it. If you're using Twitter, you can just use the hashtag #StarParty and we'll get it there. Or you can watch it over on YouTube, and we're glad to answer any questions that you have. So I can see a bunch. Amanda Stevens says, Amanda Stevens says, I have a laser. Yeah. I think that's going to go down in history.
Hey, I think I'm going to turn that into my text notification. I'm going to go through and download that.
Yeah, I have a laser.
You can release it on the Android market.
When Fraser sends you a text, it'll say, I have a laser. Yeah. So Stuart, what are we looking at here?
This is NGC 2169, also known as the 37 cluster, and I rotated it and cropped it so we can actually see the 37 in it. And it's an asterism. They're just randomly lined up like this, but it's kind of cool. It's not the 42 cluster, but it's the 37 cluster.
We still haven't found the 42 cluster.
No, we have not.
Yeah. We should.
So it's NGC 3639.
2169, I believe.
2169. Yeah, I totally screwed that up. Okay. 2169.
A little off there.
But this has become a favorite, and someone asked for it like about a month ago, and it was great. Actually, if anyone caught the episode of the Star Party where we actually saw it for the first time,
Nicole,
it's absolutely classic because we're all like one by one, turning our heads and recognizing the 37, and Nicole takes about another minute or so and says, "Oh, I see it," and so I did my presentation to the Science Online conference in North Carolina, and I was able to sort of present that snippet of video, and it was great to see 500 people all going like this, all at the same time, and then Nicole goes, "Oh, I see it," and the whole crowd just laughed. So it was.
We
great
love you, Nicole. She's out of town right now, but I'm sure she'll watch this later. But we love you.
Yeah, and then I asked Nicole,
flying her way home.
Yeah, and then I said, "Nicole, do you see it now?" Yeah, in the middle of the crowd. It was great. It was great. But that's a fantastic art. Are there more stuff like this? I mean, there's the coat hanger cluster, but the problem is it's such a wide field of view, right?
No, this one is actually, well, the coat hanger cluster is very wide. Gary might be able to get it, actually, in the summertime.
I think he's tried. I think I've
tried, yeah.
Yeah, it's even too wide for Gary.
Yeah, it's a binocular one.
Yeah. Cool. All right, well, so Mark has brought us the moon, and this is the enemy tonight.
The enemy.
Yeah. Since the dawn of time, mankind has wished to destroy the moon.
It's a stunningly beautiful enemy that will even be more beautiful tomorrow on full moon.
Yeah. We are 1 day away from the full moon. And so, I don't know, Mark, can you digitally zoom over onto that left-hand side where we've got the Terminator?
Which do you want? The Terminator.
Just get some, the edge, the craters.
What little bit of it there is.
Yeah.
It's over there.
Yeah.
It's over there on the
moon. It's on the moon?
Yeah. Terminator's on the moon. Yeah, so you can really see that we get very little of the shadows now.
Looks like my focus isn't perfect either.
Well, now's your chance to fine-tune it with this zoomed-up mode.
See, the problem is I have to run up and down the stairs to go out to the telescope to do it.
Oh.
Fail.
Ready, go.
It's called
Did you get
budget
the text
astronomy.
message? The virtual star party started. I got there.
What is a clear? How cold is it when it's clear there in Chicago?
Well, it's actually pretty warm tonight because it's right above. It's right below freezing. It's actually at freezing right now, 32 degrees Fahrenheit, which is actually pretty balmy compared to what it's been like the last week or so, where it's been like 5 or so Fahrenheit.
Yeah.
I have to put Fahrenheit on it because I know you, Fraser, are that whole metric thing.
Yeah, it's 16 Celsius right now, so I love you guys.
Actually, it was pretty warm today, but now there's like a weird storm that's blown in today, and it's like really hard wind and rain coming sideways at us. So.
Oh no.
Yeah, so I'm glad I don't have a telescope. So T. Martin 1899 asks, can you explain why when I look through my Orion Nebula through my scope, I don't see that amazing red color? Pamela?
Your eyeballs aren't that sensitive is the problem. Our eyes have 2 different types of photosensors. Some of them simply go light, no light, and my camera's over here. Those ones that go light, no light are sensitive to all the different colors. They trigger very easily. You may not realize it, but whenever you're in low light conditions, you don't actually see color, although your brain may fill in color for things that it knows. You also have, mostly concentrated in the center of your vision, color receptors that are sensitive to red, green, blue. And so they will only trigger when they see enough red photons, enough green photons. And in low light circumstances, or looking at faint objects through telescopes, you just don't get enough light hitting your eye to trigger the color sensors, so you're only triggering the more peripheral black and white sensors. This is why when you aren't sure you can see something through a telescope or not, you should actually look slightly sideways inside the eyepiece and use your peripheral vision to try and see that galaxy or star cluster.
It's even like just with the sky. I mean, you look up into the sky and you can often notice galaxies or star clusters out of the corner of your eye, and then when you look directly at them, you can't quite see them. So It's the same thing going on. Well, I'm going to move over to Gary's new view of the Horsehead Nebula and a satellite.
And 2 satellites.
Oh, there's there are 2
One's
satellites
across
in there.
here. And for those that don't know, the reason I can tell it's a satellite and not an airplane is because there's not flashes going through it.
Yeah.
When it's nice solid light, it's a satellite.
And Lewis, you had a similar photo up just a second ago. I don't know if you could bring that one back. Your version of the Horsehead. That would be great.
Sure.
Yeah.
Let me find it.
Is there a third satellite, or is that a hot pixel? Like, right, sort of where the satellite that's moving sort of more vertically, just to the left of it. There's like another little line there.
On mine?
Yeah.
Oh, yeah. Yeah, no, that could be another satellite going by.
3 satellites in the same.
Going to hit each
Show
other.
off.
There's all sorts of junk up there. It's very annoying.
Yeah.
I just tried to do an image of M31 and I hit my house.
Oh,
You hit your
move
house?
your house.
Yeah, I had to move my house.
Yeah.
In that your house got in the way of your image, or your telescope actually bonked into your house?
My house. No, my house got in the way of the image.
Okay, all right. Yeah, because we see that in the virtual star party video that has Gary in it, right? He actually bonks his telescope right into the camera, I think.
Yeah.
Too close.
Too close.
That's great. Cool picture. Okay, so I'm going to show you. So this is Gary's, and this is what, a 2-minute exposure, Gary?
This is a 2-minute at, again, hydrogen alpha. And this is the
So that's, we're
here.
looking at the specific shade of red made when an electron goes from the 3rd energy level to the 2nd energy level in a hydrogen atom, and a photon is released, so you have to have energy in order to get red light.
And the Flame Nebula here. And right here is Alnitek, I believe it's the left-hand star in the belt of Orion.
Right.
That's right. Yep.
And Eric Briggs says the Horsehead is very close to the celestial equator, so there is a larger risk of hitting geosynchronous satellites in the image.
Yeah.
Ah.
So there's why you've gotten a ton of satellites in your view.
Although geosynchronous wouldn't go through that fast.
Yeah. So one of the reasons that the LSST cadence for in the future, when the Large Synoptic Survey telescope comes online, is set for what it is so that it doesn't accidentally image spy satellites that are moving very slowly, imaging very set areas of the planet. So yeah, some of these high things,
Who watches the watchers?
Yes.
I think those are the telescopes down at Whitestone Missile or White Sands Missile.
Yeah, I'm sure they have plenty of big telescopes that watch spy satellites.
I think it's Gary.
Yeah.
I've seen your telescope, Gary.
Yeah,
I watch everything.
He's watching all the satellites. Yeah, yeah. That's
More
like
than I am behind the curtain.
All right, let's move over to Chris's view of Jupiter here. So it's a little hazy today, Chris.
I think most of it's from the bright moon. I can't really pull any more detail out of it.
Yeah.
And I'm using a junk camera, so I'm just using a regular $15 computer webcam, so can't expect a whole lot out of it. But
don't you normally run a DSLR?
Yeah, but not for my planetary.
Right.
I haven't been able to pull that off.
An extra
like Corey
webcam.
has. Yeah.
Yeah.
So I use a Logitech webcam with a Barlow and.
Right. So I'm going to move to Mark's view again, and he's got. Did you run down and fix your focus, Mark?
Yeah, actually I had to run up, so I'm running upstairs because I'm in my basement, so I have to run upstairs to go out on my back patio, put my slippers on so I don't get snow all over my socks.
Well, I wasn't going to demand it, but I really appreciate your your dedication to the cause.
Oh, it looks way better. I'm taking video
way
now
better.
so I can stack it.
Yeah, look at that. That's beautiful. Pamela, which craters are those? No, I won't
No
ask.
idea.
No idea.
I love how the fact that you can see that it's so close to the full moon there that right on the ridges of those craters on the Terminator, you can just barely see the light coming over.
Yeah.
It would be so interesting to stand like on one of those craters and see across the crater and see that shadow moving up.
It would be so cold and hot.
Cold enough. Yeah. as you asphyxiated and boiled.
But you get the view.
Spacesuit.
Yeah, spacesuit. Yeah. That would be amazing. Yeah.
That would be really cool, though.
Yeah. You just watch that all day. Neat. Now, are there any parts you can get any more detail on, Mark? Because you're using the digital zoom, right? Yeah.
Yeah. I'm using the 5x digital zoom. So this is my full frame view right here.
Yeah.
If I wanted to get any closer, I'd have to switch out my optical train and put an eyepiece in and do some projection. But this is just prime focus.
No, it looks great. It looks great. But
your movie looks really good.
If you want to sort of explore around on that 5x, even the 5x zoom looks fantastic.
What would you like to look at?
Some Moonanites.
Surprise us. Yeah.
Some Moonanites.
Some Moonanites.
Where are those moon weasels at? Yeah, so much about it.
They're visiting the moon,
whalers
man.
on the moon, right?
You can find one of the flags.
So somebody asked for M33, which we could do, I guess.
I can try. It may be a little low for me, but I can give it a try. I've got M35 right now.
Okay, all right. Sure. Tom Nath asked a question, which I don't know if we know the answer. How fast does the lunar Terminator move?
That's a good question.
Yeah.
How?
Don't everybody jump in at once.
No,
We're waiting for Pamela to get back.
Pamela dropped just in time. Isn't that convenient?
I'm back now.
I know you're back now. You missed it. Just in abs. No. Tom Nath asks, and you might have to do some math. How fast does the lunar Terminator move? So if you were standing there and watching the Terminator move, or if you were standing in it, could you outrun the Terminator, I wonder?
I don't know, but I can do that math, and we'll have it tomorrow for Astronomy Cast.
Nah, don't worry about it.
Segue.
I mean, it'd be fairly simple math to
well, let's see.
about.
Yeah, because it would take.
It's
28 days
28
to move
days.
through the full cycle, and
then it's 2 pi r for the distance that it moves if you're at the equator.
And the moon is
I just don't know the value of r. Let me look it up and do it. You guys look at something. I'll run the calculation right now.
That is awesome. Okay, thank you, Pamela.
Okay.
Tom, hang tough. Pamela will run your calculations for you.
Yes. So I've got a calculus exam coming up, Pamela. I'm just going to have you on my phone a friend, and
yeah.
No?
Can everyone include you, Pamela, as their phone a friend if they get their space question?
Space questions, yes, not
Yeah,
calculus questions.
Chris Skzer on YouTube says that last USA Monday morning was flying at 37,000 feet and saw a view of the Large Magellanic Cloud, and it was amazing.
Oh, wow.
Yeah.
I'm jealous.
Tyrian 2006 has calculated as 15.4 kilometers per hour.
That sounds about right. Hold on. Keep going. I'm continuing to fail.
Yeah. All right. So we're going to move to. Sorry. So Stuart, you had.
This is M35, and the M35 is an open cluster near Orion, and that's sort of the one in the lower part of the image. And if you look, there's a little fuzzy bit up and to the right of it. That's another cluster that's completely unrelated to M35 and much, much farther away, and I forget the name of it. I don't have it open to look it up. It's some, NGC.
It's an NGC object, yeah.
I'm not sure what it is, but nevertheless, I just like M35 because you can see the two little clusters near each other.
It's neat to have a cluster within a cluster, right?
Right.
Eric Briggs predicts that an astronaut could outrun the lunar Terminator. So, and Teal is guessing 370 kilometers a day at the equator. So.
Or 15.4 kilometers per hour at the equator, yeah. And that's another thing to think about, too, at the equator, because when you're talking about that, it's going to be at
Okay, I'm getting 370 kilometers per day.
Yeah.
Yep.
Yeah. Okay. Other people Google faster than I do.
Right. And so turn that into per hour, right? Which is 15.4. Yep. So Tyrian 2006 gets the award.
You get a high five from the internet.
Are you faster than a PhD astrophysicist? Yeah.
Yes.
Yes. All right. Well, I'm going to move to Gary's view of the monkey head, right?
That is it.
Nice.
Oh, it's rotated.
And if I rotate it, well, I didn't rotate it because if I go this way,
Yeah, it's there. We go.
Now you
Monkey.
can see it, but it doesn't take up the whole screen.
Ooh,
That's
ooh,
okay.
Eyes and brow, nose.
Yeah.
I remember when you
I
first
love
showed
this
this.
one.
This thing was awesome.
Yeah.
That'd be the monkey head.
I'll have
And
to
if we
dig
saw
up that
this in
post.
color, it would be a beautiful red image.
Yes,
A red monkey.
but I probably couldn't see it from here.
Right.
Yeah, that's true.
Yeah, I think it's really important to know that with Gary's view, he's got this very specific, as you mentioned, he's viewing this hydrogen alpha. He's got this really tight wavelength that can get through the horrible light pollution he has in the Los Angeles area. So it's either this or nothing, right?
Pretty much. Yeah, without the filters, I can get some, but nothing spectacular.
But it's great to take that telescope. I know you've taken that telescope on the road a few times, and
I have.
yeah, and it's got to just be stunning at places like Joshua Tree or
Yeah.
Yeah, out by the Salton Sea. Done a few there, but I'm getting a little too old to do that anymore.
I've told you, if you want to go anywhere, I've got a strong back. We're pretty close.
All right.
that'll come
I'll be your
along for the
patch
ride. That'll come along for the ride too. So
Okay.
yeah,
I'll be your
There you
patch
go.
mule. All right, Gary?
It's a road trip.
All right.
We've just
I'll
decided.
take you up
Okay,
on it.
and Lewis, you're going to show us something from the past.
Yes, here's an image of M33 from October a year ago. And
Millions of years ago.
yes, a long time
That's
ago.
beautiful.
It's a stack of 8 images, each 300 seconds long, of M33 that somebody asked for.
That's really good.
Whoa, eight images,
Each
300 seconds. Yeah,
Yes.
okay.
And that's how you get all the nebulosity, all
Yeah.
of the knots in the arms, and you can really start
Yeah.
to see the dark lanes as well.
Yeah, I mean, people need to really understand that what we do with these virtual star parties is quick and dirty, and 2-minute exposure is as long as we will tend to do them
Yeah.
for really faint objects. But to do this kind of stuff, sometimes people are producing images that they've spent all
Yeah.
night on one image. Hours and hours of light gathered together and merged together and stacked to produce these really detailed images.
Yeah, and I find in many cases I'll spend almost as much time doing the image processing after the fact as actually acquiring the image to pull out the detail. And
I do way more time because I don't know what I'm doing yet.
Right. So as your skill improves, your time decreases. So Sylvan Westby says that M35's companion is NGC 2158.
Attaboy.
There you go. That's
Go
cool.
team.
Go team. Thanks, Internet. It's like we've got a bigger brain. So I'm going to go back to this moon. I got to say, when it's like this full moon, it is a nice image. Although it's nice when it's like a little less than this. Could you do anything about that, Mark? Could you decrease the age of the moon a little bit?
Yeah, can you go back in time a little bit? Do your Superman, fly around backwards.
Yeah, grab the moon.
You
pull
know,
it back.
if I had those kind of superpowers, do you think I'd be hanging out with you guys on a Sunday night?
Possibly.
Possibly,
Yes.
yeah.
Probably,
Yes.
yeah, actually.
Yeah.
All right. So I'm going back to Stuart's view here, and it's like, is this the double cluster, Stuart? No.
This is the double cluster, yeah. So it'll be one of the last images of the double
Yeah.
cluster of the season because it's pretty low. This is actually a very, very pretty thing that you can see with binoculars, and it's one of the first things that you can see with just a visual telescope, and it's very, very pretty just in an eyepiece. And I actually think this is one of the things that's prettier in an eyepiece than it is, when you're trying to image it.
what I find really neat about the double cluster is that red star in between the two elements of the cluster that actually is, the color seems to be pretty easy to discern in the telescope, by eyeball as well.
Yeah, I pretty much squeezed out all the color just to kind of get the star glow. I mean, the sky glow out. So all you're just seeing is white and black here.
It's not really resolving for me. I'm not sure if it's a connection thing or something.
I'm seeing.
Okay, it resolved here.
Did it? Okay. It could just be my view of it then.
Could be your sideways rain.
No. No, but I can see the thumbnail for, I don't know. The Hangouts have been acting a little funny this last week, actually. I don't know if you've noticed that. On Friday, we couldn't mute Amy.
Yeah.
To hear a title, and she was having a lot of like noise with her microphone. There was no way that we could mute her, and I didn't see myself in the thumbnail, but I saw myself on the big screen. So anyway, this is just clearly Hangout nonsense, but hopefully we can get to the bottom of this. What am I going to do now? I'm going to go back to the moon. I've decided. Chris, are you clouded out there?
I think he ran off for a second.
Did he run off? Okay, all right.
So
Sorry,
I actually am going to be evil and share an image from earlier this evening that I took. Where
Is
you
this
can
live?
No, sadly. This is about 3 hours old, 4 hours old now, of the moon down near the horizon, and you can start to see the moon illusion. The moon doesn't change size as it gets up above the horizon, but when you see it down near the horizon, it can seem much, much bigger, just because our brain sees it near objects that we understand the size of, and then I exaggerated it even more using a high-power lens.
Oh, okay. Now I'm seeing they're like right above that silo.
Yeah, right above the silo. It's a very faint moon. Tonight, the moon was still up while the sun was up, or it rose while the sun was up, and tomorrow the moon rises 10 minutes after sunset here in the St. Louis area. And I wanted to see if I could capture all the snow in the harvested cornfield, and the answer was sort of kind of maybe.
Now, can you show that other picture that you took, the one of the sun, was it the sunrise or the sunset?
Sunset. Yeah, hold on. That's a different. That was in here.
Go ahead.
So this is the sun setting over a frozen horse jumping arena, and what you're seeing is the pattern that the water made as it melted more where there was particulates in the snow and less where the snow was cleaner, and you end up with this weird dimpling effect and scattered light. And you can also start to see how the sky, depending on the thickness of the atmosphere, varies with color. And I got a time series that actually exemplifies Rayleigh scattering really well. So when the sun is high in the sky, you see nice blue sky, white snow. But then as the sun sets, everything gets redder and redder as we're seeing the sun through more and more atmosphere. And so it's strictly an effect of how much atmosphere the sunlight has to pass through. And just the difference between these two and how orange the light appears to come through, that's what produces the golden hour that photographers rely on. And you can really see that the light of everything does get redder and redder through the evening. And then we have moonlight. So Rayleigh scattering
really nice
is the photographer's friend.
So
yeah,
I did a time lapse. I'm sure I'm going to be able to not going to be able to show it, but did a time lapse of the moon, which maybe it's going to work. This isn't going to work very well. Hold on, let me see if I can do it.
And that's one just to show off.
Let's see if this is working here. There's me. But I really want. We'll go back to the moon. Oh no, we're gonna go to Stuart's view. Actually, Gary's got a new view too.
Got the M1.
We were killing time, so now we're back. Okay, I'm gonna go to Gary's view first with M1.
Yep.
Which is the namesake, the image, the icon we use for the space community on Google+, which happens to be the largest community on Google+.
Woohoo!
And in color, this is much prettier because all I'm seeing is the hydrogen.
Right.
I'll give you an idea of that here in just a second.
Oh, nice. Yeah.
This is the Crab Nebula M1 or NGC 1952.
And this is, I mean, this object detonated as a supernova within, historical times, right? This is about, what, 1054? I always get it wrong.
And what's awesome about this one is we've actually been able to see over the period that we've had photography, so just over the past 150 years or so, the expansion rate, and we can measure how quickly it's expanding just by seeing the knots and filigrees slowly overcome the surrounding stars. There was a really neat activity done by Sky and Telescope probably about 10 years ago that you may be able to get your hands on in a local library.
That's really cool. It's like the V, was it 838 Mon?
Mon, yeah.
Yeah, right, where they get a view of the Hubble Space Telescope, and you can kind of see the expansion of this nova event, and then a few years later they did it again, and you get more expansion, and then you time lapse it. You can see just the changes of this material coming out of this star. I mean, you think when you see these objects that they're all very stable and very static, but actually these things are changing in the sky in front of us, and this supernova remnant that we see only detonated 1,000 years ago, and a few thousand years from now, this thing will have faded away, so that it's not very visible anymore. That what look like these very bright objects that we see in the night sky are sometimes, very temporary.
And the awesome thing about V838 Mon is it's two flashes that are two different colors that are propagating out, so you end up with all sorts of interesting color mixing as the light reflects back at different times and different places. And the material that the light's reflecting off of is material that was in the past blown off by the star. So it created this and illuminated this all for itself.
Well, I'm going to move to Stuart's view, and I have no idea what we're looking at.
Yeah, that's why it's a horrible picture. This is a comparison to the M33 that was shown before.
Right.
This is a 2-minute shot, low in the sky, near a street light, with a moon sky, with a dust mote in the middle of it.
Was it uphill both ways?
Yeah, uphill both ways.
Okay.
Just to show the difference between a quick image and a long exposure image, and why long exposure astrophotography is so important.
Yeah.
And so you can barely kind of see it's really horrible, but I just threw it in just because I took it. It's nice for a comparison.
I'm seeing it looks almost like ripples. I don't know if that's.
Yeah, that's no, that's artifact from, because in order for me to actually see it, I had to do just a heavy histogram stretch in Photoshop.
Okay.
Otherwise, it would have just been totally dim, and so that's artifact from that.
Okay.
Now, Tom R. is asking, with the Crab Nebula, what kind of star would it have been before it exploded?
Hot one.
A big one?
So there was recent research that figured out what type of progenitor star it was. I don't have it off the top of my head. I believe it was a single large star that exploded, but let me verify.
I'm going to move back to Chris's view, and he's got the whole moon here.
He's got the whole moon in his telescope?
In my telescope.
Yeah, totally.
I was having a little trouble with everything here, and it's excruciatingly cold, -3°C here.
Oh dear.
Oh man. Well, we're only going to make you suffer for another like 15 minutes or so.
I'm all right. I've got my hand warmers, and I got stuff in my boots, so touching all the metal parts on the telescope is just what's cold.
I feel good. It's 45 degrees F here, and we're freezing.
Oh, yeah. Thanks, Gary. Yeah.
I'm glad to help.
I'll be polite in the on-air version of the Virtual Star Party.
What's this, Stuart? Is this?
Yes, I gave in to the inevitable.
And yeah, this is the you need to keep your enemies closer, right?
Yeah, exactly.
Right. Know your enemy.
Right. So this was taken about, I don't know, 3 or 4 minutes ago. So it's I think it's called the moon.
I think it's.
Is it a moon?
Yeah.
Someone's moon? Yeah.
Might be ours, I don't know.
Yeah.
3 or 4 minutes ago. That's not live. Come on.
No, I know. But just
Stuart.
to be clear, right? This is Stuart's view as a photo, as opposed to what Chris and Mark are doing. Chris and Mark
they're
are
doing
live.
videos. I'm actually running, Mark, I'm running 2 computers, so I'm imaging with one and then I'm broadcasting with the other, so I have to transfer the file from one to the other. It's the only way that I can make it go with Gary's program.
So I've got a request here for M64, the Black Eye Galaxy. Is that up?
I will find out.
I don't know. So to go back and finish answering the question on the Crab Nebula, its progenitor star is actually somewhat curious. It may have been a Wolf-Rayet star that had an obscene amount of stellar mass loss due to winds. One of the problems they have in identifying exactly what the progenitor was is the mass of the surrounding nebula and the mass of the neutron star in the center of the nebula don't quite add up to what people think they should add up to, so there's a missing mass problem. It was definitely a core collapse supernovae, so giant star, sort of like the ones that we saw in the Orion Nebula earlier this evening. Giant stars that had massive amounts of mass loss, burned up their cores, hit that iron core point, and underwent core collapse and supernova explosion.
We lost Fraser.
We did.
So I just checked in. Yeah, Lou's confirmed as well. M64 is really, really low on the horizon, so I don't think we'll be able to pull that up there. Which that was for, I think, Jamie. Sorry, Jamie. We won't be able to do that this week.
Chris, are you the one that has this strange Cylon noise?
I'm not sure.
Can
Could
you
be.
try muting?
Yeah,
Yes,
it's Chris.
so-
Yeah.
You sounded like you have a Cylon breathing over your shoulder.
That's great. So
Could be the truck sitting over about a block away from me.
No, but it
Sorry.
definitely sounds
Oh.
like it's just the microphone is picking up its own sound or something. Yeah, it's like some kind of. Yeah.
Well, I'll mute. So
Yeah.
Okay, sorry.
Who knew technology would be so complicated?
Who knew? I
If
knew.
only we had someone from Vonage that could help us with this noise canceling.
Yeah.
view.
I'm going to move to Gary's view because there's something. I don't think we've ever seen this before.
This is M78. And it's not real good. I'm pretty close to the moon at this point.
Yeah.
But it is M78. There's a lot of dark in here. This would probably be better with full color. And no, I don't think I've imaged this before.
What is it?
It's a nebula. There's a couple of nebulosities in this area.
This is
a
one.
little bit
So one of the reasons it doesn't look so great is because this is a reflection nebula. So most of its light is blue wavelengths. So it's reflected continuum light, and so your happy little H alpha filter is being rather unhappy.
Yeah.
Right. Yeah, so it's like the wavelength of light that he's able to pick up is not coming through. It's all getting blocked by that horrible, horrible light pollution.
Yeah.
Right, and I'm trying a bunch of new things, but some of them aren't working out well.
So Scott is showing us what it could look like if we, I guess, if we're just using a computer, just looking
Yeah,
at a
you-
simulation.
If you were cheating like Scott
Yeah.
was, then
Now,
Yeah, you
Lewis,
wanna
is this the
zoom
same
out on
object?
that, Scott?
Yeah, this is M78 from, I'm not sure exactly when, but this is many, many images stacked together, processed, so it's definitely cheating.
That's okay. You can cheat.
But you can see it. So if in your head you can take the two images and flip so that the big blobs are lined up, it's literally a take and flip like this. Problem between Lou's image and Gary's image. So if you can make that mental flip, you can see where the big and the little blobs of light line up. Now you need to do this.
And you can see those dark lanes
There.
through this object.
Yeah. Yeah, so now they're lined up the same, and so you can see how they line up. And the majority of this light is blue light, because the red light is getting scattered out by the blue light is getting scattered out and the red light is passing straight through. So what we're seeing is you have a cloud of material, light is passing into the edge of it from the side relative to our field of view, and then the blue light gets reflected towards the observer.
So I've got a question here from Deaf Guitarist 12. In Registax, what are wavelets and how does one use them? That's probably not a question we can answer quite quickly in DIS, but I don't know if anyone has a quick answer to that.
They're little magic sliders that I play with until it looks good.
There you go. Little magic sliders. Play with them till they look good.
Yeah, it's
Stay
like a little
tuned.
burger, right?
Stay
Go to
tuned
White
for
Castle
another
and get magic sliders.
intro to astrophotography hangout. I'm going to explain that in another one.
Right, exactly. So what I wanted to do then was pitch and advertise the fact that Chris has been doing a series of hangouts about astrophotography, and so this is a. When are you going to be doing the next one, Chris?
I haven't set the date yet, but probably within the next month, I would say.
Okay. Yeah.
I usually just try to do it on a day off. They just kind of
We
wing
don't
it.
get those anymore.
So I'm going to be doing a couple more.
I pulled
Good.
down an astrophotography book in the library that explained wavelets, and it was math that was way over my head. So,
So we'll get Stuart involved in my hangout too. So
yeah, they're magic sharpening sliders.
Magic sharpening sliders. Perfect.
I've used the wavelets in PixInsight quite a bit, and essentially the way I think about it is it's a way of being able to isolate features in the image by what their size or scale is, and then being able to apply different kinds of sharpening or enhancement algorithms to things at different scales. So, I mean, if you think about like a galaxy is a fairly large scale image, you can do something to it versus, say, softening the background noise, which are fairly small scale images. How it all works, I have no idea. It's some kind of magic, software inside.
That's it. You just keep going back to magic sliders.
Yeah. There's unicorns in the software, and they're just.
And they do math. Yeah. Math unicorns. In the
Math
software.
unicorns.
Math is
Oh
hard.
man, you're gonna make me install this so I can figure out what it is, so that I don't. See, so it's electronics that's magic, and when you see the smoke, that's the magic escaping. Software isn't magic. Software is just like nice, pretty lines of code.
Yeah, but you're the coder.
Yeah.
We always
Pretty
joke
lines.
about this that I'm the one with the computer science degree and Pamela's the one that does all the coding.
That's what happens.
Yeah, well, I think the problem is that you just, even your astronomy work, there's so much just dealing with databases and trying to get your
is.
information that you have to do coding.
Yeah.
So,
Someone's got to do it.
yeah. Okay, so Project Toxcart says that M1 theoretical models of supernova explosions suggest that the star that exploded to produce the Crab Nebula must have had a mass between 9 and 11 times the mass of the Sun. So.
Which is
you go.
true. They just can't find all the mass, which is annoying.
You just
Where did you go, math?
Wait,
Get
you
back
got-
here.
How do you weigh a cloud of expanding, gas and dust?
You can estimate the density of it based on how the light passes through it and how much scattering there is and how much color attenuation there is. And then you can measure the physical size of it based on the expansion rate, the known distance. And so they can actually do a pretty good job of saying, know the density, know the size, calculate the volume, calculate the mass, and there's not enough there. So.
So I think we've got one last object tonight, and I think then we'll have run out, and the stupid moon. So Stuart, it's hard because the moon is beautiful, but it's also evil.
Yes. My previous image was a terrible one of the Pinwheel Galaxy. This is the Pinwheel Cluster. And not quite sure why it's called the pinwheel. I don't really see a pinwheel in there.
We're all doing this, aren't we?
Yeah. But that's what this is, Pinwheel Cluster.
Cool. That's great.
Maybe if we spin around really quick, it blurs and looks like a pinwheel spinning.
Yeah, all I can figure is somebody had really bad optics.
Well, but maybe if you do like a really long exposure, then some more fainter shapes come out of the stars. No?
No, the people who named this did not have long exposures. The people who named this had worse optics, so you really do have to see things slightly out of focus to figure out why they were named.
But I always wonder, about those objects like the Pac-Man cluster, right? Like,
Yeah.
what did they call it before the game Pac-Man came out? Right?
The cheese.
You just blew my mind.
I know. So there's all these objects that they're looking for the better name because the thing hasn't been, So where's the iPhone nebula, right? Right. So these things need renaming as as we see the Segway nebula. That's all I'm saying.
No. No. Some things
the
do not
Prius.
need to be immortalized.
The Prius nebula. Okay.
Prius. No.
Oh, Lewis.
The Red Ring of Death.
Lewis
Wait, Gary has something beautiful. We can end on. Is that Andromeda?
That's
That
Andromeda.
is the
Let's
Andromeda.
and actually, it is definitely washed out. I mean, that moon is killing you.
Evil.
Mm-hmm.
Yeah. But you
You're
can.
up there laughing.
But that's a 2-minute.
Yeah.
It looks so much like a comet.
But Gary, my house isn't in your way.
I'm sorry. Move your house.
All right. Well, let's wrap this up then. So I'm going to thank everybody for joining us. Thank you very much, Chris, for bringing this beautiful fusion, this beautiful Jupiter and this beautiful moon with the dust motes. Thanks to Gary Gonnela for this wonderful view of the of Andromeda. That was fantastic. Lewis, thank you for digging into your archive and showing us what it looks like when you cloud. Oh, look at your tagline, clouds. So sad. Yeah. So that's what you can do when you do big long exposures. So as you said, here in the show we are just giving you just a sneak preview of what you can do if you spend a whole night getting a view. Thanks, Mark. It was great to see you again. I haven't seen you in months, so it's awesome.
I hope to be on more often when the weather cooperates.
We're bringing the band back together, so this is great. Dr. Pamela Gay, and we're going to be recording an episode of Astronomy Cast tomorrow, topic unknown.
Oort cloud. I Skyped it to you.
Okay, let's do the Oort cloud. That sounds great. We're going to talk about the Oort cloud tomorrow, which is really appropriate because there's tons of comets this year. This is the year of the comets. Scott Lewis.
The year of the dragon, but okay.
Is it the year of the dragon? The year of the dragon comets. Scott Lewis.
Yes. Yeah, everyone get ready. If anyone's in the Austin area in 2 weeks, we will be down at South by Southwest doing our virtual star party from down there. Also, so yeah, Friday, Saturday, and Sunday in 2 weeks, we will all be down there. Fraser, Pamela, Nicole, myself. We'll be there with NASA and the James Webb Space Telescope doing some outreach, doing our hangouts, doing some citizen science with CosmoQuest. So if anyone is either attending South by Southwest or in the Austin area, it's going to be free. So you can all come down there, see the full-scale model of the James Webb Space Telescope, and we would love to come say hi.
Yeah, if you want to find us, just look for the gigantic, life-sized James Webb Space Telescope model.
Yes, it's the size of a tennis court.
It's the size of a table. It would be hard to miss, and we will be sort of in the area, orbiting the model, so it will be easy to find.
Yeah.
Zilker Park, for those of
Zilker
you who know the area.
Okay, all right.
Be in Zilker Park down by the river, or Town Lake, depending on what you want to call it.
And Stuart Forman, thank you very much. And if you could move your house for next week, that would be really much appreciated. All right.
Yeah, so we'll see you next week.
All right. All right.
Yeah, without my house.
Oh, there's Chris. Very cool.
You just made Stuart homeless. Do you feel, you feel good, Fraser?
I was just too lazy to walk up the hill today.
I thought you went uphill both ways.
In the snow.
Awesome. Okay, well, thanks everybody. Thanks for watching, and we will see you all next week, and then live from Austin the week after that. So,
Wow.
we'll see you in a week.
Good night, all.
All right.
Bye, everyone.
Good night.
So those aren't actually moons of Jupiter, unfortunately.
Newfound storms, maybe.
Yeah. We got Gary Gonnela. Hey, Gary.
Hi, guys.
We got Louis Bamakos, who he's showing us an archived photograph. So definitely not a current photograph. But he's clouded out tonight, but he's going to join us for color commentary. Maybe show us some of the pictures that he's done, because he's got some beautiful, beautiful pictures that he's taken. We got Mark Berendt in Chicago, and Mark is showing us also the Orion Nebula.
Hi
This
guys.
is great. Mark was one of the first people to join us back in the, like a year
Back in
ago
the
in the star
day.
parties. Back in the day, yeah.
He's so old school, Mark.
He's
I am.
totally. Got Dr. Pamela Gay, my co-host on Astronomy Cast. Whoa, where's that coming from? Oh well.
That was my
Mark.
phone vibrating, telling me that the virtual star party just went live.
Oh, okay, yeah. Thanks.
Hey, guess what, Mark?
Virtual Star Party's gone live. So, hi everybody. My name is Fraser Cain. I'm the publisher of Universe Today, and it's time for your Virtual Star Party for February 24th, 2013. So once again tonight, we're going to hook up a whole bunch of telescopes into a live Google Plus Hangout, and we will show you the night sky. I said to mute, Stuart. We're going to show you the night sky live. So we're going to show you, we got a nice live view of Jupiter tonight. I think we'll be able to get the moon, although it's almost full moon. We're going to be able to get a bunch of deep sky objects to be able to show you as well tonight. So I think it's going to be a good night. Now the problem is we've got this almost full moon, which is going to be pretty bad news for being able to see a lot of the deep sky objects. So we're going to have to kind of deal with that. So joining me tonight, we've got this is great. It's like a reunion of a lot of the people who joined us early on. So we've got Chris Ridgway.
Hello.
Hey, Chris, and he's showing us this view of Jupiter tonight.
Not very well, but
Not very well.
got a transfer to dust across the face of it.
Yeah, you've got a couple of. No, we're going to call those transits of dust motes.
Orion Nebula, there's 4 stars, which are called the trapezium. And Pamela can tell us more about the science behind those. But you don't normally see those in our M42 shots because we take 60 to 120 second, shots, and this area gets completely blown out. And you'll see that in my next picture I'll show. It is completely blown out. You cannot see them.
What I think is great is all through the summer, everyone is asking us to show them images of the Orion Nebula, and the Orion Nebula is down over the summer, and then it comes up in wintertime, and then we're going to get, we get really beautiful pictures of the Orion Nebula, and now we have 4 of them. So for all the people all the summer long who asked us for images of the Orion Nebula, here are 4 simultaneous images of the same object. But yeah, so you can see here, I'm showing you Gary's view right now, and you can really see how just the center of the nebula itself is just a big white blob, with the rest of the nebula, a lot fainter, and it's a lot more, subtle. But that core part is just so bright. Yeah. Just in. So Dr. Pamela Gay, my co-host on Astronomy Cast, she's going to bring the PhD astronomy knowledge tonight. Scott Lewis, my co-host for the Virtual Star Party.
Hey, everyone.
The person who does all the things. all the things. And Stuart Forman, who's located in San Francisco and is showing us this beautiful view of the Orion Nebula as well. And what's really great about this picture is you can see the trapezium, which are those 4 stars right at the heart of the Orion Nebula, and because he's done actually a very short exposure on this picture. So, Stuart, do you want to talk a bit about this picture?
Sure. This is a 10-second exposure at ISO 400, so it's pretty dim. But I did that specifically since I didn't want to blow out the core. And and it's also very heavily cropped. And I have an uncropped M42 kind of in the queue here, which I'll show you in a second so you can see the difference. But in the middle of the core of the...
That it's just white. And then with Mark's view, same thing. You can really see... Mark, you can really see the trapezium in there, just the 4 stars.
Yeah, if we go in pretty close, we can see the trapezium in there, and you get some of the finer detail in that big blowout area. The real trick is to get a bunch of exposures across all sorts of different ranges so you can get some detail on everything. Yeah,
it's one of those. It's that technique of doing the high dynamic range, the HDR, and that's how you get those really cool images. We see a lot of them on Google Plus, right, where they'll take an image at a really short exposure, and then they'll do a medium exposure, and then a bit of a longer exposure, or different apertures, and then they'll merge that image together, and so you get detail on both the sort of fainter items, but also detail on the stuff that would be really bright and be overexposing the rest of the image, and you can really see that subtle detail. But these are just one exposure that people are doing. And then here's Stuart's view, as promised.
Yeah, so this is the uncropped view in my